In this video, I'm going to explain ARM LPC2148 LPC C program to find the factorial of a number. So I'm demonstrating using KEIL 4. So here you have to open new item to the source group. I'm adding C file, so you can give factorial number. So I am giving the name as fact.c, and here you have to type the program. So I already have typed program, so I'm pasting that. So I'm explaining the program now. So you have to include first line include LPC214X. X means you can have 2142 or 2148 any series. So header file you have to include that. Next include stdio.h and void uart underscore init. So you have to initialize the UART. UART stands for Universal Asynchronous Receiver Transmitter. I will tell you the theory part of that. So LPC2148 UART. Okay, UART stands for Universal Asynchronous Receiver Transmitter. Okay, U means universal, A means asynchronous, R means receiver, T means transmitter. It is a serial communication protocol in which data is transferred bit by bit at a time. So UART serial communication protocol uses defined a frame structures for data bytes. So you can see the frame here. Okay, it contains start bits and data bits packet. So you can have start 1 bit start bit, and you can have data packets of 5 to 9 bits. Usually we recommend we use 8 bit in a packet. Okay, and stop bits. Okay, stop bit is also 1 or 2 bits. You can see in this given frame, one start bit is there. This is a set of 8 bits. This is a data byte. It's a 8-bit data byte. 11010010 is just some random data, 8-bit data, and one stop bit used. After that, this is ideal. So this is called as framing. Basic framing structure. Start bit and stop bit. Within between that, we have one data byte. So this is a UART is a serial communication protocol defined frame structure. Defined frame structure. So this is the frame structure we are going to use. And LPC2148 has inbuilt UARTs, two inbuilt UARTs. So they are UART 0 and UART 1. Okay, UART 0 and UART 1. There are two inbuilt UARTs are there in LPC2148. So what are the features of UART 0 are? It is a 16 byte receive transmit first in first it out, first in first out. FIFO means first in first out. It has built-in fractional baud rate generator with auto bauding capabilities and software flow controller through transmission enable bit. TX means transmit, EN means enable bit in transmit enable register. Similarly, some of the features are there for UART1. Since we are not using UART1, I'm going to skip this. So these are the pins of LPC2148. You can see the pins used in here: transmit data, receive data. TX means transmit data, RX means receive data, and these are the UART pins. Okay, transmit data 1, transmit request to send, clear to send, data set ready, data terminal ready, data carrier detect, etc. So important pins are TX D0 and RX D0, which is serial transmit data pin and serial receive data pin. So these are the pins I already explained. So some of the registers you should know. Okay, so that is UART 0 registers are receive buffer register. So U stands for USART, 0 means USART 0, UART 0. RPR stands for receive buffer register. It's an 8-bit read-only register. This just contain receive data. Whenever you send, if you receive the data, this will come to receive buffer register. Okay, so you can read this part. Okay, similarly, THR. It is U0 means UART 0 transmit holding register. It is also 8-bit write only register. Yeah, whatever data you want to transmit, the data must be transmitted. The data to be transmitted is written to this register first. Okay. So some of the values you have to set here. You can see that. So U0 DLL and U0 DLM. Okay. DLL stands for divisor latch LSB byte, least significant byte. DLM means MSB. Okay, divisor latch MSB. These are two 8 read write registers. So you should have some values. This will be used for to calculate the baud rates. Okay. So your divisor latch holds the value by which peak clock, that is peripheral clock, will be divided. This value must be 1 by 16 times the desired baud rate. So we are going to set some values for URDLL, URDLM. So you know this formula. Okay. You have to set these values. So we are going to set some values for those two registers. So the formula for finding the baud rate is UART baud rate is given by P peripheral clock divided by 16 into 256 into U0 DLL value plus U0 DLL value into 1 plus div value by mul value. So this formula, if you read these values, this we can set the baud rate to 9600 out of 4800 and all. Okay. So you can go through this theory. Important points I already highlighted. So one more important register is U0 LCR. It is a line control register. So we have to set the value for 83. Okay. We have to set LCR value as 83, where 8 means 10000011. Okay, 8 means 1000. 3 means 0011. So last two bits are 11 means we are using 8-bit character length, and bit 2 is 0. We are using one stop bit. 0 means one stop bit. If it is also 1, then it is two stop bits in the protocol. And we are disabling the parity generator. 4th bit, 5th bit, we are making 0 odd parity. Anyway, we are not using the parity here. And last, the 7th bit, MSB bit, we are making 1. So that is going to enable divisor latches. And one more register is LSR, line status register. Okay. So this value we are going to set to 1 or one more value. I think bit number 5 we are making into 1, and this one. So if we have some receive data, then we are going to end with 0 1, so that we are going to check receive buffer data. Receive buffer registered actually contains valid data or not. Okay. Similarly, one more transmitter holding register, whether it is empty or not, we are doing AND operation and we are checking. Okay. So these, how to program UART 0 means, first you have to configure port 0.1, port 0.1 as TXD0, RXD0 by writing 0 1 to corresponding bits in pin select 0 register. After that, using U0 LCR register, you have to make DLAB as 0 and set approximate value of U0 DLL and U0 DLM depending on what peripheral clock is used. So usually we are going to set 9600. For this, using this formula, put mul value as 1 and div. These are the on reset. These two values are already fixed. So substitute and you can calculate values. Okay. So you are going to get approximately 97. Okay. So you can set the U0 DLM value as 0, because sum of these two should be this much. Sum of these two should be this much. So if you substitute DLM is equal to 0, we are assuming this as 0. So 256 into 0 is 0. So DLL will be 97. Okay. So these are the how to initialize UART means. You have to first step here, these are the steps I already explained. Initialization in terms of code, it is this. First step is you have to enable those pins TX naught and RX naught of the UART 0. So that is possible by doing pin select 0 is equal to pin select. This is logical OR operation. Logical OR operation with this 32-bit data. So it is going to make particularly 5 means 0 1 0 1. So those two bits are becomes ones, and it is going to enable RX naught and then TX naught, and we are loading UART 0 LCR register with 83 to follow this call. Then DLM and DLL values are set to this. So we have the 96 value, 97 not DLL, that is in decimal. If you convert into hexadecimal, it becomes 61. So we are setting this value here. DLM value is this, and after that we have to make once again LCR is equal to 03 to make DLB is equal to 0. So we are locking this protocol. We are setting the baud rate using this. After that, how to check receive character and how to check transmit character, you have to follow this. So now I'll go to the program. Okay, here we are going to use all those details. That's why I explained the 10 minutes introduction about UART. So in the Viva, they may are going to ask what is UART. So you should be know why you are going to set these values. So void UART 0 in init. So we are going to initialize the UART 0. We are enabling transmit and receive pins. We are setting 8 bits, no parity, one stop bit. But to set the baud rate, these two DLM and DLL value should be this. Okay, and this line will make DLAB is equal to 0. So in order to send character to UART 0, okay, void UART underscore send character C is a function we are declaring. We are calling actually. So while UART 0 LSR and with 20 bit. So we are before checking, we are checking whether you have to go that you have to go there. Okay, which which is this LSR? Okay, I will show you once again. LSR. This is LSR, line status register. We are going to do logical AND operation with logical operation with we are going to do logical AND operation. We are going to do whatever value present in LSR, and we are going to do logical operation with 20H. 20 means last 8 bits. Okay, out of 32 bit, last 8 bit is 0, 0, 1, 0 and 0, 0, 0. So that means here, okay, 0, 0, 1, 0. 20 means 2 will come here, 0 will come here. Okay, this fifth bit. Okay, fifth bit should be 1. So what is the fifth bit? You can see here whether the transmitter holding register is empty. We are checking continuously there. Okay, we are going to we have to send character, no? So this is not. So if you do logical AND operation, if there is a register, if there is a bit in the THR register, then it is 1. Okay, then you are going to do AND operation with this. So and 1 is 1, not of 1 is this. So if the until valid character comes, it will wait there only. So once the valid character comes, so this becomes 0 and not of 0 is equal to 1. So while true, we have to send a character through this. So unit THR should be loaded with that character. So you are 0 receive character. Here also you are going to do AND operation with first bit. Okay, LSR first bit, that is this one RDR, that is receiver data ready. So you are going to do AND operation with this value, whatever value is there. Suppose this is empty. Suppose this is empty. This will be 0. This will be 0. Okay. And we are going to do AND operation with 0 and 1. Okay. This all bits are 0, only this bit is 1. So we're going to do AND operation with 0 1. Okay, if it is 0 and this is 1, this results in 0, and not of 0 is 1. So here also you remember like that, if until it is 0, okay, receive buffer is 0. Okay, I'll show you that. Until receive data ready, that is until you receive, until it contains valid data, it will be wait there only. So once if you receive valid data, so it is going to return this u naught or pr value. Similarly, to send a string, this is a function. So C function I will not explain. So you add 0 send string constant char star str. We are using pointer here. So you add send character, uh, the content of this array, and after that increment will take place. So you add 0 receive int void. So int number char C, while 1 we have to enter number. Okay, because we have to find a factorial of some number, so we are actually calling one function to enter a number. So we are receiving some int value from the UART. So that time it will check whether carriage return or new line. If those two are pressed, then immediately it will come out of the scanning mode. If you enter valid number between 0 to 9, ASCII value of 0, it should be greater than or equal to 0, and this is AND, logical AND, this is OR. So when it is going to come out of the loop is if you enter carriage return or new line, it will come out of that scanning mode. Okay, if you enter any, if you press any key between 0 to 9, it will check ASCII value of 0 should be equal to or greater than 0, and this is and less than 9. Then we are going to send that value. Okay, number is equal to number into 10 plus C minus ASCII value of 0 we have to subtract. Okay, so whatever number you are going to enter, number is equal to number into 10. Initially number is equal to 0. So now we are going to multiply that number into 10 plus C is a character which you are going to enter. For example, if you enter 9, okay, it is going to give you 39. Out of 39, you are going to subtract ASCII value of 0. That is, ASCII value of 0 is 30. ASCII value of 9 is 39. So you are going to get only 9 actual value, and you have to return that number. We are declaring one more unsigned long factorial int n. If n is equal to 0, then the factorial is equal to 1. You have to return. If you want to try to factorial of 0, it will return 1. Else it will return n into again factorial of n minus 1. Okay. Again, if you call a factorial of n minus 1, again if this result is 0, it returns 1. Else again it will return n into again n minus 1. So this will recursive. Okay. Then in the main function int main. Okay, int main int num unsigned long fact. So because factorial we are going to get for 9 factorial more, so we have to declare as long. Long is up to I think 32 bit. Char means 256. Okay, 8 bit. Int means 16 bit. Long means 32 bit. Then char buffer is equal to 50. It's an array of type char. 50 characters you can enter. Now in the main function we are calling UART init 0. If you call this, it is going to initialize. It is going to initialize UART 0 with this rule. Okay. After that, we are calling receive int. We are going to send one message here through UART. Okay. Send string enter number. Enter the number. Okay. Enter the number to find the factorial, or enter a number to find a factorial. Okay, you have to give some space whatever you enter now, it will come next to this. So after that, it will receive. So we are going to call UART0 receive int. That is already declared here. UART0 receive int. So here you have to enter 0 to 9 only. And if you press enter button or next line, automatically it will come out of that receive int mode. Okay. So now, and whatever you enter, it is written is there now. So we are going to subtract ASCII value of 0. So if I enter 9, 39 will be there. From that 35 is subtracted, the actual number will return. So after that, so number is assigned with that value. Okay, you are send string. This is again slash r slash n means new line. So next we are calling find the factorial. Okay, fact is equal to factorial of num. So factorial of num is this. So whatever number you are going to enter, that is actually number here. That number we are assigning to num, and we are calling this function. So if I enter 9, okay, 9 is compared with 0. So it is not equal to 0. So it is going to do 9 into, it will call 9 minus 8, factorial of 8. Again it will, 8 is compared with 0. Again it will do n into, so n is every time it is going to return n into factorial of previous. Okay. So n into factorial of, we are calling one more recursive. So it is factorial of 8. Next, when you are calling 8, so it is 8 into factorial of 7. When you are calling 7, it is 7 into factorial of 6. Again, 6 into factorial of 5. So it is recursive while coming out of all the recursive. So finally, we are going to end up with factor. It is equal to 9 into 8 into 7 into 6 into 5 into. So you are going to get a factorial of 9. So after that, we have to print it on the screen only. So you are send string, this is new line, fact is equal to factorial of num. So we are using sprintf buffer. We are already declared buffer with 550 size. So in that buffer, we are printing, okay, factorial, okay, factorial of percentage d. Okay, percentage d means whatever we entered num now, that will display here. Factor, for example, I entered num as 9. It will display factorial of 9 is, and fact is declared as long, unsigned long. So percentage lu. Again r slash n is new line, and after that we are sending this buffer. In the buffer, first it will print. After that, we are sending UART0 underscore string, send string that buffer value, and return 0 and end. So this program you have to type. Okay, you need to type all this. I can share this. You can. I'll share this in the description. You can directly copy and paste, and you can execute. Okay. Just understand, we can reduce, okay, this program instead of scanning and all. Just we can directly give the number, and we can find factorial. I will explain that also. Actually, this is a lengthy program. This is actually professional way of writing the program. I can reduce this program only for 40 lines, and there where no need to scan the number and all, and we can execute. Okay. So first I'll explain this. After that, you can see one more my video. Okay, now I'm compiling this program. So we are getting 0 errors and 0 warnings. Actually, we have to include source dot h also. Here I have to include dot s also. Let me check 1 minute. You have to open serial window. You have to view serial window. View at 1. View serial. There are 4 serial window. You at 1, you at 2. So you at 1 I am using. So this is a window. If I run this, I think you have to include startup file. 1 minute. I will do Actually, for assembly program, no need to add this file. So I will redo it. Just I will redo it once again. Project, uh, close project. I'll do fast. Okay. Project, new microvision project. So you can create one more file. Okay. Here you type LPC 2148. See here. Copy startup.s. If you are doing C file, you have to include this file. For assembly file, it's not required. It is already exist. Okay. Now I'm going to add new item to the source group. C file. I'm doing factorial. So here I already copied the file. So this should be there. Startup file should be there. I pasted a comma is there, so it is not correct. I'll delete this file. Here to add new item, don't give comma and all. So fact dot c and compile it. So zero errors. Now start debug. Okay. Now open serial window. This is serial window. Okay. Now you have to click run button here. This run button, or you can click this also. Step over. You can, if you want to execute step by step, you can do this. Otherwise, now it will directly run. This is run. So it is showing enter the number to find the factorial. For example, you click on this and now you have to type. So it is now in scan mode. Okay, get it is now doing this receive int void. Okay, receive int void this functionality. Now we have to enter either 0 to 9. So I am entering 9 or 5. Okay, and it is not break. Now if I enter, press enter button, then see either you have to enter carriage written or enter button, then it will go to the break. So now I'm going to press the enter button. See, now it came out. After that it executed slash n means next line it came, and after that it calculated factorial, and next it is sent factorial of a number. Percentage d means it is taken 5. Okay, factorial of a number is 5, and it is actually printing the return value, which is fact. Okay, fact is 120. So factorial of 5 is 25 into 4 into 3 into 2 into 1 is actually 120. Again, it is asking enter one more number. I am entering 7. So 7 factorial is 5040. Again, I will enter 2. 2 factorial is 2 only. 3 factorial is 3 only. Let me check 0 factorial. So 0 factorial is 1 because here we return if n is equal to 0, return 1. So this is actually professional way of writing the program. This is actually lengthy code, but it's a good code. I can reduce this instead of I can avoid all these things. Okay, scanning and all. So I will show that one also in the next video. Please take it. Thank you.